I was having some problems with my EV charger, and for that matter, it just shut down one day and would not charge. So we're going to check it out and see whether it's a problem with the charger or a problem with the car. And I guarantee it's not a problem with the car, it's a problem with the charger. But let's find out what went wrong with this one and whether I can actually fix it. So today I'm going to talk about electric vehicle charging equipment, or EVSE, the electric vehicle service equipment. This is the charger that you would have in your garage, or your portable charger that you would use to charge your vehicle up, and how it communicates with the car, because I've just had a failure of mine, and we'll show you how it failed, and we'll take a look at some of the signals that are missing on the scope, and we'll compare it to a good one. And then I'll be doing a video when my new charger arrives. I'm going to replace it with a new one, and we'll swap that one out when it arrives. But you have to understand how these things operate and how they communicate with the car. It's actually very, very simple, because everything's done with basically one control line. And there's 5 on a standard 1771 connector, which is your level 1 or level 2 charger. There's 5 pins on the plug, and they're kind of like arranged like this. So you've got your, well, let me go get a plug, and we'll look at the actual plug itself. So looking at the plug, and as you can see, I got power. It's not that my charger is dead. I got power. The fuses or nothing are blown. It just won't charge the car. But what we have here is we've got 5 pins: L1, L2, ground. This is pin 1, pin 2, pin 3, and pin 4 and pin 5. And all 5 are used by the car, but there's actually only 4 wires. In the case of this one, there's a 5th wire only because this one's got a light, but most of them only have 4 wires that actually go between the car and the actual charge unit itself. And the schematic over here shows how they are connected. But anyway, that's the connector. So this is the representation of it here, and then we're going to test this thing momentarily to find what the fault is. So if we look at the actual connection between the car, this is the electronics on the car is here. This is the vehicle controller, the charge controller. This is the piece that goes in your garage or your portable charger. And so we look at this side. There are 4 wires that connect between the EVSE controller and the car. The 5th pin is inside the actual plug, the connector that I just showed you. That's the 5th wire. It's grounded. So there's a 1 kilohertz pulse width modulated square wave signal that's generated, and it's fed in with 12 volts through a 1K resistor. And that signal is passed down pin number 4. And what that does is that tells the vehicle what the charging current capabilities are of the circuit that it's plugged into. For example, if you were using the 110 portable charger, you may only have a 6 or a 9 or a 15 amp charger, and I actually have one. My portable charger can switch between I think a 6 and 12 amps. So we'll be able to actually look at the duty cycle. But a 10% duty cycle is telling the car it's a 6 amp. A 16% duty cycle is 9.6 amps. 25% is a 15 amp charge. A 30% duty cycle is an 18 amp charge. 40% duty cycle is a 24 amp charge. And 50% duty cycle is a 30 amp maximum. And it goes up. There's a 40 amp and there's a 50 amp, which I think was 60 and 70%. I'm not worried too much about that because most people don't have anything more than a 30 amp charge in their garage. The other ones are for commercial charging stations, which can obviously deliver more current. And we're still talking the 240 AC charger. We're not talking the DC fast charger, which is a completely different animal completely. I'm talking just the AC charger. So there's a 1 kilohertz pilot signal is supplied, which goes down to pin number 4. Pin number 4 being this pin over here. So we can measure this between ground and pin 4. This is what we're going to be measuring when I get to break out the scope. What it does is this signal is passed through to the car, And when you squeeze the trigger to release or plug in the car, it opens a switch, so that now you've got 330 ohm resistor and a 150 ohm resistor in series. That would give you about 480 ohms on pin number 5. You can see that pin number 5 has got a 5-volt supply that's fed from the car, because this is powered up from the actual controller on the car. So there's always 5 volts present on pin 5, or close to 5 volts. Just 2.7 pull down a resistor here, but typically there's going to be 5 volts when there's no load or very close to it. When you plug in the proximity connector, when you've got your switch in the open position, it's going to see the value of the 2 resistors added together, and then when you release the switch, it's going to short the 330 ohm, and you're going to have a 150 ohm load on here. That's to tell the controller in the car that you've pressed or released the button. The reason that is there is so that the car can stop the charging when you press the button before you actually pull the connector out. The car is controlling it through pin number 4. So when you first plug your cable in, even before you release the switch, release the button, the pilot signal is going to be detected by the controller in the car, and the car is going to know, hey, I'm on a 15 amp charger, I'm on a 24 amp charger. It's going to know what the maximum charge rate of this particular equipment is, what gauge of cable, because that's going to be dependent on the gauge of the cable. A 16 gauge cable, for example, is only going to charge at 12 amps, whereas a 10 gauge or 12 gauge wire could charge at 15 amps. So that signal is going to be present. The car is going to know what the capabilities of the charging equipment are before you even close that switch. Once you close the switch, the car then responds by closing a relay, which puts a 1.3K resistor on this pilot line, which incidentally has 12 volts. So there's going to be a DC voltage on here in addition to the pulse width modulated carrier. The carrier, of course, telling the car what the capabilities are. So once you release this switch and it detects that it's only 150 ohms instead of the 2 resistors combined, it's going to close this relay, which is going to then put a 1.3K resistor. It's going to add a 1.3K resistor load onto pin number 4, which is going to be detected over here in the EVSE controller. It's going to tell it that the car is ready to charge, and then that's going to close the contactors or relays to apply your AC voltage to pins 1 and 2. And depending on whether you're on a level 1 charger or a level 2 charger, if you're on a level 1 charger, you're going to have hot on pin number 1 and neutral on pin 2. If it's a level 2 charger, you're going to have your 2 hots, line 1 and line 2. So once the charger is, once you release the button on the charge connector, the car is then going to signal by means of the pilot proximity line that the car is ready to charge. The power is turned on, and then the controller in the car takes over, and the actual charger is on board on the car. The equipment in your house is actually quite dumb. All it's doing is turning the power on and off. And of course, there's also ground fault circuits and so forth inside the charger itself. And that's why I don't know what's gone wrong with mine, whether it's the pilot generator or whether it's one of the ground fault circuits that's gone bad, because the ground fault circuit will kill the pilot, which will then of course shut the car down, because if the pilot signal goes away, the car shuts down gracefully. The one thing you don't want is you don't want the contactors opening under full load. If you've got 15 or 30 amps going through the relay, you don't want the relay contacts opening up under load. You want the car to shut down first so that there's no current flowing through your main conductor, and then the controller shuts off. And it does it before, when you press the button to release the connector, it does this before you have a chance to unplug this, so there's no chance of ever having any voltage between your J1 and your P1, the P1 being on the car side and the J1. Anyway, let me grab my broken unit, and I'll grab a level 2 that works, which is a 12 amp. So let's grab the equipment and we can take a look at it on the scope. So we'll connect our scope between the ground and the pilot. and I'll show you the reading on the scope. So there's the pilot signal. This is a 12 amp charger. On the scale, 20% is 12 amps, 16% is 9.6, we'll call that 10 amps. 10% is 6 amps, 16% is 10 amps, 20% is 12 amps, 25% is 15 amps, 30% is 18, 40 is 24, and it's a sliding scale. So here we've got 1/5. If we look at the gradations there, so that's what, 20%, and that's 12 amps. So this is a 12 amp charger, and that's the pilot signal that I'm looking at. Now let me look at the one that's not functional, and you'll see that it just has DC voltage. There is no pilot signal present. So let me grab the one that's broken. There's the broken one. No pilot signal. So because there's no pilot signal, the car will never charge. Another thing we need to check is we need to check the proximity pin between ground. This is when you push the button in. So when the button's pushed in, or when the button's not pushed in, we have 150 ohms approximately. If I can make my probe make a connection here. And when I push the button in, it goes to 480 ohms. With the switch closed, 150 ohms, right? As we're looking here, 150 ohms. When the switch is closed, when you press the button in, it opens the switch, and then you end up with, go to 480 ohms, which it is. That's to tell the car to stop charging, and the car then, of course, shuts down the other line. Now, the charger is defective. When I test the same thing, we'll see that actually the switch isn't probably working in the other one because it's not toggling that, although the pilot signal is not present. But different chargers, it's an older charger, so it may actually turn the pilot off if it's not getting any proximity fed back from the car. Let's just measure it. It might even be it might even be this. It might even be the switch in here that's bad in the other one. Let me just measure that one because I haven't tested that yet. Okay, this one is completely open. So this pin has failed. The connection in here has failed on this pin. So I want to make sure that it's not just, I'm just not making a connection. We'll just stick some solder or something on there. Yeah, 8 mega ohms. Okay, I think we just found the problem with this charger. It's the connector here. That proximity pin has gone open. I'm curious as to whether this can be fixed or not, or whether I have to get a new connector or just replace the entire charger. But anyway, let's troubleshoot some more on this thing. We're getting warm. Okay, there's the plug apart. I wonder if I can get into this thing. I guess the switch is inside this. And this looks to be a sealed unit, so I don't think I'm going to have much luck seeing what goes on inside there. This is more of an exercise to see what went wrong with this, because I've actually ordered a new charger. Right now, we have a rebate through our power company that will give us up to like $700 towards the price of a new charger. All I gotta do is give them my proof of purchase. So I'm replacing it now that I can do it for free, and we're just gonna see what's wrong with this one, because I highly doubt that this is gonna be repairable. I think this is gonna be a completely sealed unit. See if I have any luck getting this thing apart. So this was my original level 2 charger that I got when I got my first Volt, and at that time we had a $500 rebate, which just happened to be what this thing cost 8 years ago. It's blown the fuses like 2 or 3 times, and I fixed the fuses on it. So now it shut down the other night while the car was charging. It went off. Like, the car was charging and it just stopped charging. I went out in the morning and I only had half a charge. I thought at first somebody had unplugged it again, but in this case, nope. The charger went bad, or the connector went bad. So I'll be getting a new one, and we'll just basically take this one apart and see what went wrong, because I doubt that we're going to be able to do anything on this at this stage of the game anyway. We'll find out when I get it apart of how this thing's put together. There's the plug apart. It's all molded into one piece. Well, this thing's been out in the weather so long, it's just deteriorating. The LED just broke off. The little light that was on there just fell right off. I think ultimately that's what's happened, is water's got into this thing and it's just corroded it. So a new plug will probably fix this thing, but I can get a new charger for a pretty good price. Because we have our rebate program on right now, I can get a full rebate on the cost of the charger. So it's not the pin here. We have continuity. I should have 0 ohms. Oh yeah, we do. So that's good. So it's not the plug itself. It's something in this molded piece, which is all coming apart. There's the little switch there that gets activated. I have to say that over the years, this thing's been, the car, I've had this for 8 years. So even if I only plug the car in once a day, that's still about 2,900 plug and unplug cycles. But sometimes I would charge my car twice or 3 times in a day, depending on how much I was driving. So it's well over 3,000 times that this thing's been plugged in and unplugged from the car. And it's been sitting out in the weather, in the heat, and in the cold and freezing and rain. So it's no wonder that the thing broke down. So maybe what I'll do is I'll get a new cord for this thing if I can find one. I'll get a new plug and we'll change the cord on this one, and then I'll have a spare. Because I've ordered a new one in. I've ordered a new 16 amp charger in. But it looks like it's just the plug on here. Definitely this switch, even though the switch was turning on the light, the little LED was still working until it fell off, which it just fell off now. But I bet you this is where the corrosion is. I bet you the circuitry's probably right down in here. You can see it's all cracked and falling apart. Don't worry, guys. The power's off on this thing. But that water's gotten into this, and it's done a job on it. It's lasted 8 years though. I mean, it's been basically out in the rain and snow and baking out in the sun. It's been in use for 8 years, so it doesn't really owe me anything at this point. But that's the sensing wire there. That gray wire. That's the pilot wire. That's the one that goes to the switch, and in here with the 150 and 330 ohm resistor that connects to this and then goes back to ground. So inside here it goes through that switch and a resistor network and back to ground. Anyway, that's all I can show you on this thing. Thanks for watching, and we'll do another video if I get around to changing the cord on this, but I'll definitely do one when I change the wall-mounted charger. We'll catch you later.